Here we have three problems that are actually Witting reactions. They are examples of the Witting reaction which allow us to convert a carbonyl compound into an alkene. Let's see that. So I'm going to start with this one here because it has explicitly the steps that we need to follow when we're forming the Witting reagent. This is called an aldehyde. And notice it has a negative and a positive next to each other. So negative on the carbon and the phosphorus being positive here. But we're going to do it here. So how do we generate the aldehyde, which is my Witting reagent? So this is done this way. You start from an alkyl halide. So I'm going to do it here. What it is remember that when your periodic table, where do I write that? Let's say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Well, it's kind of squeezed, right? But right under here, fluorine, chlorine, bromine, iodine, right? Under the oxygen is the sulfur, so phosphorus is right under nitrogen. So the same number of valence electrons. So that's why I wrote those, the dots there. So this is triphenyl phosphine. And if you did this with a nitrogen, it will be triphenyl amine. So this is the same type of compound. So this is a good nucleophile. So what we're doing in the first step is a nucleophilic attack here. Over to the alkyl halide. So what is it we're making? In the first step, the product will be, I'm going to have PPH3. But now notice that phosphorus has 4 bonds. So this is 0 formal charge. If it's got 4 bonds, this is formal positive. So the next step, this is the product of reaction 1. Then I add a very strong base. So N-butyl lithium is, let's say, N-butyl lithium is this. Let's draw the structure. This is a conjugate base of butane. Lithium is simply the counter ion. Alkanes have pKa of 50, very, very weak acid. So this is very strong base. What it does is I'm going to remove one of the hydrogens here, the one that's right in the carbon connected to the phosphorus here. So removing that with this base will create the following. I'm going to have now a pair of electrons right here, PPH3. What we do next is I'm going to do a resonance structure in the movement that I show there. So now I'm going to have a double bond. Remember that you can do that with phosphorus. You can expand the octets for phosphorus. Here you have 3 bonds to phenyl, so 3, 4, 5 bonds, so 10 electrons around. You cannot do that with nitrogen, but certainly with phosphorus, sulfur, chlorine, you can do that. These are third period in the periodic table. So that's in the form of here where you have the negative and the plus, this is your aldehyde. But I drew the resonance structure of that. That's your Witting reagent. And what you're doing in the Witting is inserting this in place of the O. So that's the strategy. And so the third step is actually my carbonyl compound. So now I'm going to insert this where the O is. So my product will be, I'm going to do here, this sounds too low a little bit. So here I am doing, in place of the O, I'm installing this. So I can have, so 1, 2 carbons, 1, and here that. That's one possible. So inserting, I did the CH3 on the side, but I also have another possible compound that I can draw, which is having the 2 metals like this. So these are the isomers, and here we go. I was missing that. So remember that you need to use the nomenclature E and C to assign the configuration of the alkene here. And when assigning that, you look at the priorities of the groups attached to the vinylic carbon. Here you have an ethyl and a methyl, so the ethyl has higher priority over the methyl. And here you have at the other carbon, you have a phenyl and a methyl. These are higher priority. So the two highest priority are opposite sides of the double bond. That is the E alkene. And here you have, is that the same what I wrote? Phenyl ethyl, so higher than that, higher than that. But drew the same, so that's not it. So now I have the two metals on the same side. I can see that the two highest priority are same side. And so that is the Z alkene. Okay, so now that we have this, let's do the other two problems. So now I know that this halide will have a resonance structure just like this. So the halide here will be, the resonance structure will be 1, 2, 3, the 3 phenols, and then I will have here a CH2. And what we're doing next is simply inserting this in place of the O. So my product will have, this is 3 pentanone, and then here I simply have an alkene. All right, now next is this one, and I'm going to have to erase some of that. And you're going to keep the final products. So here you had the E and the Z, right? Just trying to make it cleaner here. All right, so what is this? Let's draw the halide now in this form, the resonance structure. So I will have CH, and this is 3, and then I'm gonna have double bond BH3. And now what I'm doing is inserting this in place of the O. So what is I'm gonna keep my metals here, and now here I will have, now it is an alkene, but now this is a CH, and I'm gonna have a metal group. Okay, and so that is how you would approach on that. So always remember that what is that you're inserting. So if you're giving an halide in this form, it's probably easier to draw the resonance structure like that. And then here you will see that what is attached to the double bond, so, and here you will have the phosphorus, that's what you're inserting in place of the O.